Hey folks, how's it going? Mr. Murray here, coming to you with a video on rational arithmetic. Alright, so in this video, what I'm going to be doing is I will be breaking down how to add, subtract, multiply, and divide rational functions. And this video is meant to kind of accompany handout 2-5 from the 2020-2021 school year. Alright, so again, in this video, I'm going to talk about how to add, subtract, multiply, and divide rational expressions. And I'm going to be showing you kind of like the basics, the steps, along with some examples. No specific you-try problems from this video. However, I do encourage you for any of the problems we're doing, if you feel like you're in a good place, that you can pause the video and try to do the problems and see what I got. Alright, but there's not going to be any explicit you try problems. Alright, so I'm going to start by going over the process behind addition, subtraction, multiplication, and division. And this works very, very much like any kind of fractions that you guys have done in the past. So kind of like adding a half plus a third. We use this example a good amount in class. So when we add like a half plus a third, right? The first thing we need to do is we need to make the denominators the same. And once we make the denominators the same, we can go ahead and add across the top. So similarly, what we're going to be doing is we're going to be factoring the denominators. We're going to be finding that least common denominator with the factor denominators. We're going to be setting both denominators equal to the least common denominator by multiplying by the same thing on the top and the bottom. And then we're going to either add or subtract across the top, depending on if we're doing addition or subtraction. Finally, if needed, we will want to simplify just in case things aren't simplified. So that might require some factoring of the numerators. But mostly we're going to be focusing in this video on steps 1 through 4. Generally, if you set the denominator equal to the LCD, that's going to take care of a lot of the need to simplify, but it is possible you'll need to simplify anyway. All right, multiplication. For multiplication, we're going to factor everything, the numerators and the denominators. Then we're going to multiply across the numerators and the denominators, right across the top and the bottom. And then what we're going to do once we're done with that is we're going to cancel any common factors. All right, what's good about division is that division, we're going to use that, remember, keep, change, flip, and we're going to turn it into a multiplication problem by turning the division into a multiplication and then taking the expression on the right and flipping it, right? Doing the reciprocal. All right, and then once we do the keep, change, flip, then it's going to work the same as multiplication from there. Now, two kinds of factoring situations that we're going to focus on. We're going to be focusing on greatest common factors and quadratics. And then that does include differences of squares, such as x squared minus 1, x squared minus 4, x squared minus 9, minus 25, and so on. And so in this video, what you're going to see, and we've looked at a lot of really difficult examples in class, this video is going to focus more on the kinds of ones that I'm going to assess you on, and not that they're going to look exactly like this, but I do want you to get a sense of the level of difficulty that I'm going to expect you to be able to solve. Alright, so what I'm going to do is I'm going to kick things off with a little bit of addition and subtraction, and then we're going to look at multiplication and division. As always, you are welcome to pause any of the problems and try to do them on your own. And then unpause and see what I've got. Again, I'm not going to have any pause nows. I'm just going to kind of roll through the problems. All right. So with addition, we're going to start by trying to factor both the denominators. We're going to ignore the numerators for now. So I look on the left and I say, okay, is this quadratic? It's not. You're looking for an exponent of 2 for a quadratic. But I do see a greatest common factor. I see that 2 goes into 2x. Because it goes into the coefficient and into 6. Keep in mind it is possible for x to be a greatest common factor, so you do want to look and see if there's x's in both terms. In this case, there's not. So I'm going to factor out that 2, and when I take out the 2, I get x, because you can imagine distributing and getting 2x. and then minus 3. And now this is completely factored. I come to the right and I see this is not quadratic. It doesn't have a greatest common factor except 1, so this is done. Now to get the LCD, what I'm going to do is I'm going to take a look at each unique factor. So I have 2, I have x minus 3, and I have another x minus 3 over here, and I'm going to ask myself, does it have a bigger power on it than this x minus 3? And so again, we can't see a power, so we assume it's to the power of 1. This similarly is to the power of 1, so I'm good, and I bring the two pieces together, and I have a least common denominator of 2 times x minus 3. And so this is what I want both denominators to ultimately be equal to. Now what I'm going to do is I'm going to come down here, I'm just going to extend my page, and I'm going to rewrite this initial problem, except I'm going to rewrite it with the denominators factored. And that's not such a big deal because we've kind of already done that. And I'm going to ask myself, look, here's my LCD up here. Do I need to do anything to either of the denominators to add on to it so that it's equal to this LCD? So on the left, I'm good because this is 2 times x minus 3, 2 times x minus 3. But here, I have an x minus 3 and I'm missing the 2. So I'm going to multiply by 2, so I get the 2 times x minus 3. And then what do I do to the bottom, I also need to do to the top. Remember that when you multiply by a number by itself, it's the same thing as multiplying by 1. And when you multiply by 1, though it's going to look different, right? We know that when you multiply by 1, the value stays the same. So what I'm left with is 3 over 2 times x minus 3. Multiplying across the top, I get 2 times 2 equals 4. On the bottom, I get 2 times x minus 3. And then because the denominators are now equal, I add across the top, giving me 3 plus 4 equals 7. And remember, with addition and subtraction, you do not do anything to the denominator, right? It's almost like adding 3y and 4y. You get 7y. You don't mess with the y's, you just mess with the coefficients, okay? It's similar in that nature. Okay, so again, I really encourage you to rewind and kind of review anything if needed, and then in a moment I will move on to the next problem. Alright, now we got a little bit of subtraction, but the idea is still the same. So the first thing I'm going to do is what, folks? I'm going to factor the denominator. So here we can see a quadratic. It is important to be able to factor quadratics. I did say I'm not going to be asking you to do any grouping. I'm not going to be asking you to do any of the kind of more tough factoring, but you are going to need to factor quadratics. So here I'm looking for two numbers, and they need to add to -3 and multiply to -4, and that's going to be x minus 4 and x plus 1, because -4 plus 1 is -4, and -4 times 1 is -4, and -4 plus 1 is -3. Over here, I'm not going to be able to do anything. Oh, it's just x minus 4. And now I'm going to look at the rather different factors. So I've got x minus 4. I've got x plus 1. I come over here, and I really ought to clean this up, make it a little bit nicer. This is x minus 4, but I already have an x minus 4. Let's check the powers. This is a 1. This is a 1. So I'm good. I bring everything together, and I get the LCD, least common denominator. That's going to be x minus 4 times x plus 1. Okay, so that is what I'm shooting to make both denominators equal to. All right, so remember next, folks, what we do is we're going to rewrite with everything factored, right? We can do this because writing x squared minus 3x minus 4 is equivalent to writing x minus 4 times x plus 1. And here's my x minus 4. I'm just going to throw that in parentheses. And now I ask myself, is each denominator equal to the LCD, or is there something that I need to do to make it equal to the LCD? So I look on the left and I say, oh, yep, I'm already good. I got both pieces. On the right, I am missing an x plus 1, right? I got my x minus 4, but I need to put in there my x plus 1. So I'm going to go in there. I'm going to drop in my x plus 1, okay? That's really important. All right, so on the left, we don't expect anything to change. We've got 6 over x minus 4 times x plus 1 minus, and let's do a distribution, 2 to the x, 2 to the 1, minus 2x plus 2 over x minus 4, x plus 1. And now again, both denominators are the same, so you subtract across the top. And this is going to be tricky. So you have 0. Now, I like to do standard form. I'm not going to be super picky about this, but standard form would be nice. So we have no x's on the left. We have 2 x's on the right. So 0 x's minus 2 x's gives me negative 2 x's. And then 6 minus 2 gives me 4. Another hack you can do, you can make this addition, and then you can flip all the signs. That will give you the same answer. Okay, this over x minus 4, x plus 1. Again, you do not do anything to the denominator. You leave it alone. Now that's the tricky part, right? A lot of people get the strategies for multiplication, division, and addition, subtraction mixed up, kind of having to do with the fact that we're going over the top to do the final step, but you do want to make note of the differences there. Okay, again, folks, please feel free to rewind if needed and take another look, and then I'll move on in a couple seconds. All right, guys, again, at any time, feel free to stop and take a crack at this. I'm going to take things up a notch, and I'm going to be basing this off of a really kind of challenging factoring situation. So if we look on the right, on the left that is, okay, we're going to have to remember this is a difference of squares. That one's a really tricky one. So remember, x squared minus 25, that's x plus 5 times x minus 5. On the right, okay, we look, all right, it's not a quadratic because the biggest power of x is x to the 1. Is there an x in both of these? There is not. Is there a number that goes into both of these coefficients? There is. It is 5. And what do we have? X, because 5 times x gives me 5x minus 5. Okay, let's set up our LCD. We have an x plus 5, that is. We have an x minus 5. We have a 5. And we have another x minus 5, so we check the powers. This one's to the 1, this one's to the 1. So we leave it as is, and we'll bring together those common powers, different factors, that is, my apologies. And we're going to put our number first, so we're going to do 5, x plus 5, x minus 5, okay? Now this is a unique situation because we're going to have to be manipulating both at the same time. So what I'm going to do is I'm actually going to do a little copy, paste, and I'm going to bring this down. It's going to kind of save me a little bit of time, and then let's just mess with the denominators. All right, here we go. All right, so I'm going to bring down the original denominators, x plus 5, x minus 5, and this one is 5, and then x minus 5. So I come to the LCD. Remember, the LCD, sometimes you hear me call it in class the target. Okay, this is what I want the denominators to be. And so I'm going to ask myself, is the denominator equal to it or not? Okay, so now for the first time, if you look at the left-hand side denominator, it's missing that 5, right? There's a 5 in the LCD, but not here. So I'm going to multiply the top by 5 and the bottom by 5, because when the 5 comes over, when it multiplies, it's going to be equal to the LCD. On the right, I've got the 5, I've got the x minus 5, but look, I don't have the x plus 5. So I'm going to multiply this by x plus 5 and x plus 5. All right, here, the 5 will go over. 5 and 2 gives me 10. And then I get 5, x plus 5, x minus 5. And what I'm going to do on the right, I'm going to distribute. So I've got 7x plus 35 over. Now, the order that you do multiplication doesn't matter, so I can write the x plus 5 before the x minus 5. Okay? Because the order that you do the 5 and x minus 5 and x plus 5, those don't matter because you're literally multiplying 5 times x plus 5 times x minus 5. And this allows me to see more easily that the denominators are the same. And now I add across the top. So I've got no x's plus 7x's, 10 plus 35. Over 5 times x plus 5 times x minus 5. Now people are going to say, Mr. Murray, can't I cross out this 5 and this 45? You cannot do that because 7x is not being multiplied by 45. It's being added to 45. So if you had 7x times 45, that's when you can cross that out. Because when you cross out 5 and 45, what you're saying is that dividing by 5 is somewhat undoing what's going on with this 45. And if it was multiplication, that would be true. Because division is undoing multiplication, but it does not undo addition. So you cannot divide out this 5 unless both the 7 and the 45 were divisible by 5. Okay, so this is going to be our final answer here. All right, everyone. So as you can see, I'm going to be moving on to multiplication soon. We're going to do one last subtraction. This is with a double quadratic, and I encourage you to try to pause the video and do it on your own before we get started. You're welcome to do that. All right, I'm going to set up the factors. So I see two quadratics. Okay, so I'm going to remember GCF and quadratics. That's what we're going to focus on. So here I've got x plus 3 and x plus 3. Now, if they are the same, we do need to note that this is the same thing as x plus 3 squared. Because when you multiply something by itself, that's like squaring it. So that you do have to note. That's the only time where you need to rewrite it like that, when it's the same thing. And here we have x plus 3 and x plus 4. And that's because 3 times 4 is 12 and 3 plus 4 is 7. Now we're going to do the LCD. So the LCD, okay, we come and we see x plus 3 and we see x plus 3. And now is where the powers matter. Because this one, there's only one of them, but this one, there's two of them. So in the LCD, we want x plus 3 squared. We're going to choose the bigger power, and then we're going to take the x plus 4 from the thing on the right. Okay, we don't want to forget about that. And this is what we want both denominators to be equal to. This is the LCD. Okay, so again, we're going to rewrite. And once you really get into the motions of it, you'll see it's not so bad. It's tricky, though. I don't think this is easy or obvious. It's definitely tricky. Okay? Definitely tricky stuff. That's part of the reason why, at least this year, I'm letting people use notes on that quiz. Because this is stuff that, and I know if the notes are tough, you don't know how to use them, but it's tricky stuff. If I left it up to memorization, it's really, really adding some barriers that to me aren't necessarily worth throwing in there. But again, that's my 2 cents. All right, so now I'm going to go through. I'm going to ask myself, all right, what's going on? What's missing here? Well, all right, on the left, what are we missing? We're missing an x plus 4. See, this is x plus 3 squared times x plus 4. This is only x plus 3 squared. So we're going to need to add in an x plus 4. Okay, and even though this is complicated, we're never going to factor out or like expand out the denominator, so I'm not really worried about that. Here, we only have one x plus 3, right? To make it squared, we're going to need another x plus 3. And you can even see there's two x plus 3s on this side on the left, if we go to the black writing up above, but only one x plus 3 on the right side. Okay, so I'm going to go x plus 3. And now I'm going to have to do some distribution. So I distribute the 7 to the x. I get 7x. I distribute to the 7 to the 4. I get 28. And this now becomes x plus 3 squared, x plus 4. On the right, distribute 5 to the x, 5x. Distribute 5 to the 3. I get 15. And the x plus 3 comes in and becomes x plus 3 squared, x plus 4. Okay, folks, so now we've done this. The denominators are the same. We'll go ahead and add across the top. 7x minus 5x is 3x. 28 minus 15 is 13. Okay, over x plus 3 squared, x plus 4. All right, this one's a super tricky one because it involves a few things at once. It involves factoring a quadratic, and it involves something squared. So there's a lot of moving pieces that we got to understand, but that's why we continue to work at it. All right, so folks, anything you need to go back, rewind, and recap, I encourage you to do that. Then in a moment, we're going to go ahead and we're going to move on to multiplication and division. Okay, folks, so now we're on multiplication. So just as a quick recap, multiplication, we're going to factor everything. We're going to multiply across the top and the bottom, and then we're going to cancel any common factors. So here we go. Let's start by factoring everything, and I'm going to rewrite as I do that. So x plus 7 up top. On the bottom, there's a GCF, so 7 times x plus 5, because 7 goes into 7 and 35. There's no x's in both terms, so I don't take out an x. Up top, I need to take a look at this quadratic. The bottom, I can't do anything, so I'm going to leave it as is. I'll put it in parentheses, though, as a good practice to just keep things in parentheses because we're going to be sticking them together. I need two numbers to multiply to negative 40 and add to negative 3. So I'm going to do negative 8 and positive 5. Now we're going to multiply across the top and the bottom. Okay, so up top, x plus 7, x minus 8. I'm not going to be super picky about the order because the order doesn't matter. So x plus 7, x minus 8, x plus 5. And then I've got 7, x plus 5, x minus 8. Now we cancel any common factors. 8's 8, 5, 5. So all that's left is x plus 7 over 7. Okay, so you can see there's a lot less work, and one big thing we want to keep in mind, at no point did we care whether the denominators are the same. That's what I love about this. You do not ever worry about making the denominators the same, because the denominators do not need to be the same in order to multiply. They only need to be the same in order to add or subtract. So again, I encourage you to go back and review any of this because this is some pretty tricky stuff. And then in a couple seconds, I'll move on to another example. All right, here's another one. So again, we're just going to factor everything we see. So 1 p minus 9, okay? In this case, there's no GCF except for 1. There's not a p in both terms, so I'm going to leave it alone. Now, I see a quadratic, so I'm going to break it into two factors. Then on the bottom, I'm going to leave it as p plus 9. All right, so two numbers multiply to negative 27 and add to 6. One of them is p plus 9. The other is p minus 3, because 9 times negative 3 is 27, and 9 minus 3 is 6. Now I multiply across the top and the bottom, so I get p plus 9 times p minus 3 over p minus 9 times p plus 9. I cancel any common factors, these two, and all I'm left with is p minus 3 over p minus 9. And if you do keep any parentheses around it in the final answer, I take them off because there's only one actual factor left. If you kept the parentheses around it, that's fine to me. It's not going to make a big difference. The values will be exactly the same, so I won't hold that against you. Okay, again, if you need to review anything, I encourage you to do that, but then in a couple seconds, I will be moving on to another example. All right, another multiplication one for us to try. So we're going to take a look. I'm going to switch colors because I want to try out blue. So we're going to go one piece at a time. So first fraction, 45x squared. There's nothing we can really do with that. Okay, it's only one term, so we're going to leave it as is. X minus 9, again, it's your standard linear. Power of 1, it's not quadratic, so the quadratic strategy is not going to work. And the numbers, the coefficients, 1 and 9, they do not have any GCF except 1, so we can't really take out a GCF in any meaningful way. On the right, we see a quadratic, so we're going to want to work that. So I need two numbers to multiply to negative 36 and add to negative 5. So I need a negative number and a positive, because a negative times a positive is a negative. And remember, you're timesing to a negative, so you need a negative and a positive. I'm going to go negative 9 and positive 5. Because, nope. Not 5. 4. Okay, negative 9 plus 4 is negative 5. Negative 9 times 4 is negative 36. On the bottom, I got a tricky one. So here, there's x's in both. So I look to the biggest power of x that I can see in both. And that's x squared. Because this is x cubed, and this is x squared. And then I can go one step further, because there's also a number, right? So 3 goes into 3 and 12. So I take out 3x squared. Now, this is x, and then you can imagine, right? X squared times x gives me the x cubed. And if you think about a 1 there, 1 times 3 is going to give me that 3. Okay? Now, 3x squared times 4 will give me 12x squared. Okay? Now I multiply across the top and the bottom. 45x squared. The x minus 9 comes over. The x plus 4 comes over on the bottom. Now, in this case, if you have things like this, GCFs, I like to put those first. It doesn't really matter the order again, but it makes things a lot easier to digest if you can do it that way. All right, so let's take a look at what we have. The x minus 9s cancel. The x plus 4s cancel. The x squareds cancel, and we're left with 45 over 3, which is the same as 15. So this is an interesting one. It actually cancels to just a number. So there was a lot going on there. We had GCFs with letters and numbers, and we had quadratics. So again, I encourage you to go through and kind of try to understand anything that might have been confusing. And then we're going to go ahead and we're going to move on to another example. All right, this is our first one with division. So let's just note quickly our division here. So with division, remember, we're going to keep, change, flip. We're going to switch the division to a multiplication, and then we're going to switch the thing on the right, the expression on the right, we're going to flip it. So we're going to do it what's called its reciprocal, and then once we do that, it will be the same thing as multiplication. So let's take a look. So again, we're going to keep the 1 on the left. The 1 in the middle, we're going to turn that into multiplication, and then we're going to flip. Oop, I got so excited I did 3x, but what I want is we're going to flip 35x plus 5 over 6. We're going to flip that. Okay? We're going to flip it. Now, we're going to proceed with the multiplication strategy. So we're going to factor everything. Here on the bottom it's tricky, but there's a 4 in 28 and in 4, so I'm going to pull out this 4, and I'm going to go 7x plus 1. Okay, up top it's difficult to see, but there is a greatest common factor. There 5 goes into 5 and 35, so I'm going to take out a 5, 7x plus 1, and then on the bottom I've got myself a 6. So I'll multiply across the top, and what I've got is 30 times 7x plus 1, right? You go right across the top and the bottom. On the bottom, I've got 24 times 7x plus 1. I cancel that common factor. I get 30 over 24. Now, if there's numericals, I'm going to hold you a lot more responsible for simplifying. If it was with expressions, that would be one thing, but 30 over 24, I am going to hold you more accountable for simplifying that. and actually 6 goes into both of them, and we kind of can see that because of this 6 that's in common here. You can actually cancel those out if you want across like that, just like you could with fractions if they were just numbers, and you would get 5 over 4. Alternatively, you could see that 6 goes into that is 30 and 24. You could similarly see that 2 goes into both of them, so you could get 15 over 12, and you could see 3 goes into 15 5 times, and into 12 4 times. So lots of different ways to get to the final answer. As long as you get to the same simplified final answer, you guys know I'm open to many different kinds of solution paths there. All right, let's take a look at another. We're going to take a look at a couple more, and the idea is the same, right? First, keep the first one as is. We're not doing anything yet. We're just going to keep the first one as is. We're going to switch to a multiplication, and then we're going to flip x plus 4 to the top, 1 to the bottom. And now it becomes just like the multiplication problems. So we're going to factor everything. Again, the reason I'm setting this up is because we see quadratics. The one on the right, there's not much to do, but I will stick that x plus 4 in parentheses. Here we need two numbers to multiply to 16 and add to 10. I'm multiplying to a positive and adding to a positive, so that's a sign that both the numbers here are positive, as in plus 8 and plus 2. On the bottom, I'm going to multiply to 8 and add to 6, and there's a similar logic. I'm adding to a positive and multiplying to a positive, so I'm going to have 4 and 2. Okay, and now I'm going to multiply across the tops and the bottoms, so I've got x plus 8, x plus 2, x plus 4, and then on the bottom, x plus 4, x plus 2, and we're going to ignore the 1, right? Because when you multiply by 1, you get the same thing. The x plus 2's cancel, the x plus 4's cancel, and you have two options. You can write x plus 8 over 1, or you can write x plus 8. I would take either. I would personally accept either answer. Many people are going to ask that you write it as x plus 8, but either way is technically correct, folks. Okay? Just want to make you aware of that. Okay, folks, so please make sure you understand this, and then if needed, rewind, and then we will go ahead and move on to another example. All right, guys, one last one. We're going to take a crack at this. Again, any of these, you're welcome to pause, and you're welcome to try it on your own and then unpause at any time. So we're going to use our strategy that we're going to use for our divisions. Okay, we're going to keep the first one on the left the same. We're going to flip that from a division to a multiplication. And then we're going to do the reciprocal on the right. Okay, then we're going to factor. So I see a quadratic up top. So I need to multiply to negative 15, and I need to add to negative 2. So I'm going to need a positive and a negative, because a positive times a negative is a negative. And I'm going to do plus 3 and minus 5, because 3 times negative 5 is negative 15, and 3 minus 5 is negative 2. On the right, I'm going to factor. Now, this is tricky. The GCF is actually 4. 4 goes into 8 2 times, and it into 20 5 times. This is a tricky one. Okay, on the right, similar, but we get now 2 is the GCF, right? 4 doesn't go into 10, so you take out a 2, and you get 2b plus 5 over 2. All right. Now you have a couple options. You can cancel the 2 at this point before you slide things across. That's actually what I'm going to do. So you get b plus 3, b minus 5, 2b plus 5 over 4, 2b plus 5. The 2b plus 5's cancel, and you get b plus 3 over b minus 5 as b plus 3 times b minus 5 all over 4. So again, b plus 3 times b minus 5 over 4. Alright folks, so those are a couple examples for you. I hope you found this video helpful. Again, the ideas behind rational arithmetic, though the examples are very tricky, are pretty consistent from problem to problem. Please make sure you understand how to do this. I hope you, again, found this video to be helpful. Just keep it up, take a positive mindset, and remember, you can do it. Thanks again for watching. Feel free to like and subscribe so you can get access to my latest videos. Don't forget to love math, and have a wonderful day.